Hello there, and welcome to the Sleeping Physicist. If you are someone who enjoys unwinding by thinking about stars, space, and the quiet structure of reality, you are very much in the right place. Tonight, we will let our attention settle into real physics and real ideas, moving slowly and carefully. Some of what we explore may sound unfamiliar, but everything we touch is grounded in how the universe actually behaves. And if you find yourself enjoying these gentle explorations, you are always welcome to like and subscribe. But for now, let your body rest, let your breathing find its own pace, and allow curiosity to remain soft as we begin. How does space-time flow according to quantum field theory? When we look around us, space-time feels almost invisible, like a silent stage that simply holds everything in place. Objects move, clocks tick, light travels, and beneath all of it, there is the steady assumption that space sits still while time carries us forward. We experience moments, arriving one after another, and it feels natural to imagine time as something that flows, like a slow current carrying events along. Space, meanwhile, feels fixed and dependable, stretching quietly between things. This picture is so deeply woven into daily life that it rarely feels like an assumption at all. In physics, this intuition was once formalized through classical ideas and later refined by relativity, where space and time merge into a single fabric called spacetime. In that picture, spacetime can bend and stretch in response to matter and energy, but it still feels continuous and smooth, like a flexible surface. Events are points on that surface, and motion is traced as paths across it. Even here, the sense of time flowing forward remains powerful, as though the universe itself is moving from past to future. If you are listening from a quiet room, or perhaps from somewhere familiar and dimly lit, you might notice how naturally your mind places this sense of flow onto everything you hear. Sounds arrive, fade, and are replaced. Thoughts do the same. It feels inevitable, as if time itself must be moving in order for anything to happen at all. But when physicists began to describe nature at its most fundamental level, this intuitive picture started to strain. The deeper we look, the less space-time behaves like a river or a moving backdrop. Instead, it begins to resemble something more subtle, something that does not need to flow in order for change to occur. And once that shift happens, the question of flow stops being about motion and becomes a question about how change itself is organized in the universe. As physics moved beyond classical ideas, space-time slowly lost its role as a passive backdrop. With the arrival of relativity, it became clear that space and time respond to what happens within them. Mass and energy do not simply move through space-time, they shape it. Clocks run differently near heavy objects. Distances subtly change depending on motion. This was the first hint that space-time is not just where things happen, but part of how they happen. In this view, space-time behaves less like an empty theatre and more like a responsive medium. If you place something heavy into the universe, space-time adjusts around it, guiding the motion of everything nearby. This interaction feels almost mechanical, as though space-time itself participates in the unfolding of events. Yet even here, nothing suggests that space-time flows. It bends, it stretches, it curves, but it does not move forward in time any more than a map moves as you trace a route across it. This distinction matters because it quietly separates two ideas we often blend together. One is change within space-time. The other is motion of space-time itself. Relativity allows the first in rich and measurable ways, but it does not require the second. Events still unfold in sequence, but that sequence does not demand a flowing substance beneath it. As physicists push toward smaller and smaller scales, they began asking whether space-time continues to behave this way when examined with quantum tools. At those scales, matter no longer looks like solid objects following smooth paths. Instead, everything dissolves into fluctuations, probabilities, and interactions. To describe that world accurately, a new framework was needed, one that could handle both quantum behavior and relativistic structure at once. That framework became quantum field theory, and with it came a quiet but profound shift. The question was no longer how particles move through space-time, but how fields behave everywhere, all at once. And in that shift, space-time's role changed again, becoming something even more subtle than a flexible surface responding to weight. quantum field theory begins from a simple but radical idea. Instead of treating particles as tiny objects moving through empty space, it treats fields as the most fundamental things that exist. These fields are not placed inside space-time like contents in a container. They are defined at every point of space-time itself. Wherever there is space and time, there are fields. An electron, in this view, is not a small bead traveling along a path. It is a localized ripple in an electron field that fills the universe. Light is not a stream of particles crossing a void, but a vibration in the electromagnetic field. What we call particles are simply moments when these fields exchange energy in discrete, measurable ways. The universe becomes less like a collection of objects and more like an ocean whose surface can shimmer, pulse, and interact. This changes how motion is understood. When something moves, it is not a thing sliding through space-time. It is a pattern of field activity shifting from one region of space-time to another. The fields themselves are already everywhere. What changes is how they are excited, how their values evolve from moment to moment. In this picture, space-time provides the coordinates that label where and when field values are defined. It tells us which events are near each other, which can influence one another, and how fast signals can travel. But space-time does not carry the fields along. It does not transport anything. It simply allows change to be ordered. Once this is seen clearly, the idea of space-time flowing begins to lose its footing. Quantum field theory describes an arena in which everything that happens is change in fields, not motion of the arena itself. And if the arena does not move, then flow must mean something else entirely. One of the most unfamiliar aspects of quantum field theory is that these fields never switch off. Even in regions we casually describe as empty space, the fields are still present. They do not fade away between stars or disappear in the gaps between atoms. They extend everywhere, continuously, without holes or edges. This means that what we usually call nothingness is not truly empty. It is more like a perfectly calm surface that still exists even when no waves are visible. The fields are there whether or not they are excited, whether or not they produce particles, whether or not anything dramatic is happening. Space is not filled with things. Space is where fields already are. Because these fields exist at every point in space-time, there is no sense in which they need to travel through it. Nothing has to be carried forward by time. Instead, each location in space-time has field values that can change, and those changes can influence nearby locations according to strict physical rules. This is where the intuition about flow quietly breaks down. In quantum field theory, change does not come from space-time moving forward. It comes from field values evolving. At one moment, a field has a certain configuration. At the next moment, it has another. The ordering of those moments is what we call time. If space-time were flowing, we would expect something to be transported along with it. But in this framework, there is nothing to carry. The fields are already everywhere they can be. What unfolds is not motion through time, but variation across it. Once this is understood, the question shifts again. If fields evolve and space-time itself does not flow, then what exactly is time doing in the equations that describe this evolution? In quantum field theory, time enters quietly and precisely without any suggestion of motion or flow. It appears as a parameter, a way of labeling when a field has a particular value. Just as a location in space tells us where a field is defined, a moment in time tells us when it is defined. Time does not push the fields forward, it simply orders their change. This is a subtle but decisive shift. Instead of time being something that moves, it becomes something that distinguishes one configuration of the universe from another. A field has one set of values now, another set later, and the theory tells us how those values are related. The mathematics does not describe time advancing. It describes how fields differ between moments. An analogy can help here, briefly and carefully. Imagine a flipbook resting on a table. The pages do not move by themselves. Each page already exists, complete and still. What changes is which page you are looking at. In quantum field theory, time functions more like the page number than like the motion of flipping. It labels an ordering, not a force. Because of this, nothing in the equations requires a flowing present or a moving now. The laws describe relationships between field configurations at different times, all treated on equal footing. Past, present, and future are not carried along by anything. They are simply different points along the parameter we call time. This does not mean change is an illusion. Change is real and measurable. Fields interact, evolve, and influence one another in ways that can be predicted with extraordinary precision. But that evolution does not need time to flow any more than a graph needs its axes to move. Once time is seen this way, the original question becomes sharper. If time does not flow and space-time does not move, then what exactly is space-time doing in quantum field theory at all? In quantum field theory, space-time settles into a quieter role. It is not something that evolves or changes within the theory itself. Instead, it provides the structure that allows change to be described. It tells the fields how far apart events are, which influences can reach which regions, and how cause and effect are constrained. Beyond that, it remains still. This can feel counterintuitive, because space-time is so often spoken about as dynamic. But within quantum field theory, space-time is assumed rather than explained. It is the fixed framework on which the fields are defined. The theory does not ask where space-time comes from or how it behaves internally. It simply uses it. Because of this, the idea of space-time flowing has no clear meaning here. Flow would imply that space-time itself changes with respect to something else, but there is nothing outside space-time for it to flow through, and nothing within the theory that measures such motion. All measurable change is already accounted for by the fields. What we experience as the passage of time corresponds to the ordering of field changes, not to space-time advancing. One configuration leads to another because the laws governing the fields connect them. The framework that labels these configurations does not participate in the sequence. It remains constant while everything defined upon it evolves. Seen this way, space-time is less like a river and more like a coordinate grid drawn on transparent glass. The grid does not move as patterns shift across it. It simply makes the patterns legible. And once that role is clear, attention naturally turns to the most surprising consequence of this picture: the fact that even when fields appear quiet, they are never truly still. Even when quantum fields appear to be completely calm, they are never truly at rest. What we call the vacuum is not an empty backdrop, but the lowest energy state the fields can occupy. And even in that state, they continue to fluctuate gently, endlessly without direction or purpose. These fluctuations are not philosophical ideas, they are measurable effects. They show up as tiny forces between metal plates, as subtle shifts in atomic energy levels, as noise that cannot be removed no matter how carefully an experiment is designed. The fields are restless not because space-time is moving them along, but because quantum rules do not allow absolute stillness. Here, the idea of flow can be tempting again. With so much activity happening everywhere, it can feel as though space-time itself must be seething or bubbling underneath reality. But the activity belongs entirely to the fields. At each point in space-time, the fields jitter slightly, borrowing energy briefly then returning it. Nothing is carried from past to future. Nothing drifts forward. The fluctuations happen locally, moment by moment, defined by time as a label, not a current. This constant activity shows that change does not require motion through space-time. It only requires that the laws of physics permit variation. Even when nothing seems to be happening, the universe is not waiting. It is already active everywhere at once without needing time to push it onward. Once this is clear, the question becomes even sharper. If fields can change, interact, and fluctuate endlessly without space-time flowing, then how does motion itself arise? How does anything ever appear to move or evolve in a world where the stage remains still? Motion, in quantum field theory, does not come from things being carried through space-time. It comes from patterns of change spreading across it. When a field interacts with another field, that interaction alters nearby regions according to precise rules. Those changes propagate step by step, creating the appearance of movement. Consider a localized excitation in a field. At one moment, it is concentrated in one region. At the next, the equations governing the field allow that excitation to influence neighboring regions. Over time, the pattern shifts. To an observer, It looks like something travelling. But nothing has been transported by space-time itself. What moves is the pattern, not the underlying framework. This is why speed limits exist in physics. The maximum speed at which influences can propagate is set by the structure of space-time, not by any flow within it. The framework defines how fast change can spread, but it does not carry that change along. The laws simply connect one configuration to the next in a tightly constrained sequence. Seen this way, motion is a story told by correlations. One place changes, which leads to a change nearby, which leads to another, forming a continuous chain. Time orders these changes. Space relates them. Space-time itself remains unchanged by the process. Once, motion is understood as evolving patterns rather than transported objects, a deeper tension comes into view. Quantum field theory treats space-time as fixed, but our best theory of gravity does not. And it is in that tension that the question of space-time flow becomes truly unavoidable. This is where the calm clarity of quantum field theory begins to strain. In general relativity, space-time is not fixed. It responds dynamically to matter and energy, bending and reshaping itself as the universe evolves. Gravity is not a force acting within space-time, but a manifestation of space-time itself changing. The framework becomes an actor. Quantum field theory, by contrast, assumes space-time is already given. Its fields live on a background that does not fluctuate, does not bend, and does not participate in quantum uncertainty. This assumption works extraordinarily well for describing particles, forces, and interactions, but it quietly conflicts with the gravitational picture. The tension appears when we ask what happens if space-time itself should be treated as a quantum object. If fields can fluctuate, why not space-time? If uncertainty applies everywhere else, why not to the structure that defines distance and duration? Quantum field theory has no place to put such behavior. Its equations require a stable stage. This does not mean either theory is wrong. Each has been tested with stunning success in its own domain. But they speak different languages about space-time. One treats it as fixed and silent, the other treats it as dynamic and responsive, and neither, on its own, describes space-time as something that flows. Instead, the conflict reveals something deeper. The sense of flow we associate with space-time may not belong to space-time at all. It may be a feature that emerges only when different layers of description are combined, and it is precisely this possibility that modern physics has begun to explore with careful patience. To address this tension, physicists have begun exploring theories where space-time itself may not be fundamental. Instead of starting with space-time and placing quantum fields upon it, these approaches ask whether space-time could emerge from something deeper, built out of more basic quantum relationships. In these ideas, space-time is not assumed at the beginning. It appears gradually, as a large-scale approximation of underlying quantum behavior. Distance, duration, and geometry become collective effects, arising only when many quantum degrees of freedom are considered together. At the smallest scales, the familiar framework of space-time may simply not exist in any recognizable form. Here, the notion of flow shifts again. If space-time is emergent, then it cannot flow in the usual sense, because it is not present at the most fundamental level. What exists instead are patterns of quantum correlation, ways in which information and influence are connected. Space-time, with its sense of before and after, near and far, arises only when those patterns settle into stable structures. This does not replace quantum field theory, it extends it. In regimes where space-time behaves smoothly, quantum field theory remains extraordinarily accurate. But at deeper levels, the theory may be pointing beyond its own assumptions, hinting that space-time is a convenient description rather than a primitive ingredient. In this light, asking how space-time flows becomes similar to asking how temperature flows inside a single molecule. The concept applies only after many components act together. Flow belongs to the emergent picture, not the foundational one, and once that distinction is made, the original question can finally be reframed with clarity. At this point, the word flow can finally be handled with care. In quantum field theory, nothing resembling a current of space-time exists. There is no substance moving from past to future, no fabric being carried along. What exists instead is ordered change. One configuration of fields gives rise to another, according to stable laws. The ordering of those configurations is what we interpret as temporal progression. Flow, then, is not a physical process acting on space-time. It is a way of describing consistent succession. When the universe evolves, it does so because field interactions link one moment to the next. Each state follows from the previous one, not because time pushes it forward, but because the laws connect them. This reframing matters because it removes the need for an invisible mechanism driving time along. Nothing needs to move for change to occur. The universe does not advance. It updates. Each moment is defined by its relationship to others, not by being carried on a stream. Once seen this way, the intuition of flow becomes something that belongs to description rather than structure. It is how beings embedded in ordered change talk about sequence. It is not something the equations themselves require, and with that distinction in place, one final layer comes into focus. The reason this ordered change feels so vivid and directional from the inside. From inside the universe, this ordered change is experienced as a steady sense of becoming. Each moment carries traces of the one before it, encoded in memory, structure, and physical records. Fields interact, systems retain information, and correlations accumulate. Because of this, the sequence of configurations does not feel symmetrical. One direction leaves evidence, the other does not. This is why time feels as though it flows, even though nothing moves beneath it. Our experience is shaped by processes that depend on order. Causes leave marks. Effects depend on what came before. Entropy increases. Information spreads. These are not properties of space-time itself, but of the physical systems embedded within it. In quantum field theory, the universe does not drift forward. It unfolds through lawful succession. Each moment is connected to the next by relationships that are stable, local, and precise. The feeling of flow arises because those relationships consistently point one way, from configurations that are less correlated to ones that are more so. Seen this way, space-time does not carry us along. We are patterns within fields that change in an ordered sequence. The universe does not move through time. It simply has moments that follow from one another. And from within that sequence, the still framework of space-time becomes the quiet structure that allows change to feel like passage, even when nothing flows at all. Within quantum field theory, time remains a parameter, but our access to it is always mediated by physical systems. Clocks are not abstract markers. They are arrangements of matter whose internal states change in regular, predictable ways. An atomic clock, for example, measures time by tracking transitions in a quantum field bound inside atoms. Each tick is not a slice of flowing time, but a repeated physical process unfolding in a stable environment. This matters because it reveals something subtle. Time, as we experience it, is always inferred. We never observe time directly. We observe change, and we compare one change to another. A clock works because one physical process is used as a reference against all others. When a second passes, nothing moves through the universe. A particular configuration of fields simply becomes another, and a trusted process keeps count. In quantum field theory, every clock is itself part of the system it measures. Its atoms are fields, its oscillations are field interactions. Its regularity comes from symmetries in the laws of physics, not from any external temporal flow. Timekeeping succeeds because the rules governing field evolution are stable and repeatable. This brings a deeper clarity to why time feels so reliable. It is not because time itself is moving uniformly, but because the laws that relate one configuration to the next do not drift. The universe changes, but the rules connecting those changes remain constant. That constancy is what clocks quietly rely on. From this perspective, the present moment is not something sweeping forward. It is simply the configuration currently being accessed by physical systems like brains, sensors, and instruments. Each of these systems interacts locally with fields and updates its internal state accordingly. Memory is just another physical record, encoded in correlations that persist. The sense of now arises when information from multiple processes aligns. Vision, sound, touch, and internal rhythms synchronize briefly, creating a coherent snapshot. That snapshot does not move, it is replaced, again and again. And because the replacement follows a stable order, it feels like motion. Quantum field theory allows this replacement to be described with extraordinary precision. It tells us how likely one configuration is to follow another, how disturbances propagate, and how energy is exchanged. But it never requires a moving present to do so. The present is simply the configuration being referenced. As this becomes clear, the flow of time begins to resemble something emergent and relational. It is not a background current, but a consequence of comparing evolving systems within a stable framework. Space-time provides the structure, fields provide the activity, clocks provide the reference, and experience arises where all three meet. Nothing in this picture diminishes the reality of time as lived. Moments still arrive, change still matters, causes still lead to effects. But beneath that familiarity is a quieter truth. The universe does not hurry forward. It does not carry anything along. It simply follows its rules, one configuration giving way to the next, while patterns within it learn how to count. One of the quiet reasons the universe feels stable in time is that quantum field theory is built around causality. Causes come before effects, not because time pushes them into place, but because the structure of space-time limits how influences can spread. Fields interact locally. What happens here can only affect what is nearby, and only after a delay set by the geometry of space-time. This locality creates a dependable order. A disturbance in a field does not instantly rearrange the universe. It propagates outward, step by step, respecting the same constraints everywhere. Because of this, events form chains rather than tangles. One change leads to another, which leads to another still. The ordering is enforced not by a flowing time, but by the rules governing interaction. In quantum field theory, these rules are exact. They do not depend on perspective or interpretation. They are written into how fields are allowed to influence one another. This is why experiments performed today behave like experiments performed decades ago. The sequence of cause and effect remains intact because the underlying structure that enforces it does not drift. This also explains why the future feels open while the past feels fixed. The equations allow many possible future configurations, each with its own probability. But once a configuration has occurred and left physical records, it becomes part of the established order. Nothing flows to lock it in place. It is fixed because it is already encoded in correlations that persist. From inside this system, the experience is unmistakable. We remember, we anticipate, we notice change accumulating in one direction. Yet all of this emerges from constraints, not currents. The universe does not need a temporal engine to keep events aligned. Causality does that work quietly and continuously. When space-time is treated as a framework, its role becomes almost architectural. It defines which events can be connected and how. Quantum fields fill that framework with activity, but they do so under strict relational limits. Nothing jumps ahead. Nothing leaks backward. Order is maintained not by motion, but by structure. This is why the idea of space-time flowing is so compelling and yet so misleading. Flow suggests transport. But what the universe actually enforces is consistency. Each moment is consistent with the one before it, and that consistency is enough to create everything we associate with temporal passage. Once this is understood, the universe begins to feel quieter rather than emptier. There's no rushing beneath events, no hidden conveyor belt pulling reality along. There is simply a vast, stable structure within which change unfolds according to unyielding rules. And from within those rules, complexity builds. Stars form, atoms bind, life organizes itself, memory accumulates, all without space-time ever needing to move. What remains is not a mystery of motion, but a deep respect for order. Space-time does not flow because it does not have to. It provides the conditions under which flow-like experience can arise, while remaining perfectly still itself. Irreversibility is where the feeling of time's direction becomes strongest. Some processes simply do not run backward in practice. A cup shatters, heat spreads, information disperses, yet in quantum field theory, the underlying laws that govern fields are, in many cases, nearly time-symmetric. They do not strongly prefer one direction over the other. This raises a quiet and important question. If the laws themselves do not enforce a direction, why does experience do so with such consistency? The answer does not lie in space-time flowing forward. It lies in how complex systems behave when many field interactions overlap. When countless degrees of freedom interact, certain configurations become overwhelmingly more likely than others. Energy spreads, because there are vastly more ways for it to be spread than to remain concentrated. Correlations grow because there are more ways to be correlated than perfectly ordered. This statistical tendency creates an arrow, not a fundamental push, but a preference. Once a system moves toward a more probable configuration, returning to the original one would require an extraordinary coordination of microscopic details. Nothing forbids it. It simply never happens. In quantum field theory, this irreversibility is encoded in how information becomes distributed across fields. Local interactions entangle systems with their surroundings. Records are formed, traces persist. As a result, later configurations carry evidence of earlier ones, but not the other way around. The order becomes embedded. This is why time feels one-directional even though space-time does not move. The direction is not imposed by the framework. It arises from the behavior of systems within it. The universe does not roll downhill through time. Rather, configurations evolve towards states that are easier to realize and harder to undo. From within this process, the arrow feels absolute. Memory accumulates. Anticipation replaces recollection. But from the perspective of the underlying theory, nothing has been pushed along. Each configuration follows lawfully from the previous one, guided by probability, locality, and interaction. What makes this especially striking is how quietly it all happens. There is no boundary where time switches on, no point where space-time begins to flow. The arrow emerges gradually as complexity grows and correlations spread. It is not written into space-time itself, but into the collective behavior of fields. Seen this way, the universe feels less like a machine driven forward, and more like a pattern unfolding according to constraint and likelihood. The stillness of space-time does not prevent change, it enables it, providing a stable structure in which order, disorder, memory, and direction can arise naturally. And within that structure, time does not need to move, it only needs to be consistent. One of the most subtle consequences of this picture appears when we ask why anything feels continuous at all. If the universe is a sequence of configurations, why does it not feel like a series of disconnected snapshots? Why does there seem to be a thread that holds moments together, giving rise to identity, persistence, and narrative? In quantum field theory, persistence is not guaranteed by time flowing, it is maintained by stability. Certain patterns in fields are remarkably robust. Atoms hold together, molecules retain structure, brains sustain activity patterns long enough to compare one moment to the next. These patterns persist because the laws governing fields strongly favor their continuation once they form. An object remains an object because the field interactions that define it reinforce one another. A memory remains a memory because the physical traces that encode it are protected by energy barriers and redundancy. Nothing about this requires space-time to carry the object forward. The pattern simply continues to exist in successive configurations. This is why identity feels smooth. Each moment inherits structure from the one before it, not because time flows, but because the universe remembers locally. Every configuration contains records of earlier ones, embedded in correlations, arrangements, and conserved quantities. Continuity is built into the physics of interaction. From within such a system, the present moment feels connected to the past and poised toward the future. But this connection is structural, not dynamic. It is not a bridge laid by time. It is a consequence of how difficult it is for complex patterns to abruptly dissolve. Quantum field theory describes this persistence without invoking a moving now. It explains why a particle detected here is likely to be detected nearby a moment later, why a signal sent continues along a path, why a living system maintains coherence long enough to experience sequence. The laws favor continuity because discontinuity is unstable. This also explains why sudden breaks feel so noticeable. When a pattern is disrupted, when a structure collapses, when coherence is lost, it stands out sharply against the usual smoothness of persistence. The exception reveals the rule. Stability is expected. Disruption requires explanation. Seen this way, time's apparent flow is inseparable from the endurance of structure. Moments feel linked because the universe is reluctant to forget. Not because space-time pushes them together, but because the physical rules preserve what already exists. And so the sense of being carried forward becomes something gentler and more intimate. We are not passengers on a moving timeline. We are stable patterns that continue moment to moment because the universe allows and supports that continuation. Space-time, still and silent, provides the arena in which this persistence unfolds. Quantum fields provide the activity. An identity emerges where patterns manage to last long enough to notice themselves changing. Nothing flows, and yet everything continues. There is one last quiet assumption that often lingers beneath the idea of flowing time: the belief that there must be a special moment called the present that advances through the universe, lighting up reality as it goes. It feels intuitive. We speak as though the present arrives, replaces the past, and opens into the future. But within quantum field theory, there is no place where such a moving present can exist. The equations do not single out a now. They describe relationships between configurations at different times, all treated with equal legitimacy. No moment is privileged by motion or illumination. Each is defined only by how it connects to others through lawful change. The sense that one moment is happening while others are not is not written into the structure of space-time. Instead, the present is defined locally, wherever physical systems are interacting and updating their internal states. A detector registers an event, a neuron fires, a memory is encoded. These processes mark a moment as present for that system alone. Elsewhere in the universe, other systems are doing the same, each with their own local now, none of them carried forward by a universal flow. This explains why different observers can disagree about what is simultaneous without contradiction. There is no single advancing slice of time to synchronize with. There are only local interactions, each unfolding according to the same rules. Space-time does not sweep a present across the cosmos. The present is continuously generated wherever fields interact. From this perspective, the flow of time becomes a story told from within complex systems that are constantly updating. The present feels alive because systems like brains integrate information over short intervals, smoothing discrete changes into a coherent experience. What feels like motion is the rapid succession of updates, stitched together by memory and expectation. Quantum field theory supports this without ever invoking a moving now. It allows each system to define its own temporal reference based on interaction and correlation. The universe does not need a global clock ticking forward. Order arises from locality. Continuity arises from persistence. Direction arises from probability. When all of this is held together, the original question transforms gently. Space-time does not flow because flow would add nothing. Everything that needs to happen already happens through lawful succession. Fields change, patterns persist, records accumulate, experience unfolds. The stillness of space-time is not a limitation. It is what allows the universe to be coherent at all scales. If space-time itself were moving, there would be nothing left to anchor change. By remaining fixed, it allows change to be meaningful, ordered and shared. And so the universe reveals a quieter truth. Time does not carry us. Moments do not rush past. There is only a vast, stable structure within which configurations replace one another, guided by laws that never hurry and never pause. From inside that structure, change feels like passage. From within that passage, stillness is easy to miss, but it has been there all along, holding everything gently in place while the universe, unpushed and unhurried, continues to become. At this depth, the universe begins to feel less like something happening and more like something maintaining coherence. Change continues, endlessly, but without urgency. One configuration gives way to another, not because it must arrive somewhere, but because the rules allow and connect them. Becoming happens without travel. Quantum field theory describes this becoming with remarkable restraint. It never introduces a force of time, never appeals to a moving backdrop, never requires a mechanism to push reality forward. It simply states how fields relate across space-time, how one arrangement leads to another, and how probabilities shape what is likely to occur next. The rest follows quietly. What is striking is how complete this picture is without motion. All the richness of the universe, from subatomic interactions to galaxies forming, unfolds within a space-time that does not advance. Stars ignite because field interactions allow matter to clump and heat. Light travels because disturbances propagate through fields. Life emerges because stable patterns can persist, replicate, and adapt. None of this asks space-time to do anything more than remain consistent. This consistency is what allows prediction. The future is not reachable because time flows toward it, but because the present configuration constrains what can follow. Physics works because the universe respects its own structure. The same relationships that held a moment ago will hold again, and that reliability is enough to let complexity build. From inside this unfolding, the sense of movement is unavoidable. Thoughts change, sensations shift, expectations form and resolve. But these experiences are local expressions of a global stillness. They are the result of systems tracking change, not of change being driven. In this light, the idea of space-time flowing becomes unnecessary, almost excessive. It adds motion where none is required. It tries to animate what is already sufficient. Quantum field theory does not deny the reality of change. It refines it, placing change where it belongs, in the evolution of fields and the relationships between configurations. There is a quiet elegance here. The universe does not need to rush to exist. It does not need a present to chase the future. It does not need a past to fall away. Every configuration stands in relation to others, connected by laws that never hurry. And perhaps this is why the deepest descriptions of reality feel calm rather than dramatic. At the foundation, nothing is being pushed. Nothing is being carried. There is only structure, interaction, and lawful succession. From within that succession, we experience time as passage. From within that passage, we search for motion beneath it. But when we look carefully with the tools of quantum field theory, what we find instead is stillness that does not oppose change but makes it possible. Space-time does not flow, it holds, and within that holding the universe continues moment by moment, not moving forward, but coherently, patiently, becoming exactly what its rules allow it to be. When all of this is allowed to settle, the universe begins to resemble something quieter than a river and more stable than a path. It becomes a vast ledger of relations. Each moment is a complete accounting of field values, correlations, and records, written consistently according to the same laws. Nothing washes it away, nothing carries it forward. Each entry simply exists in relation to others. Quantum field theory is comfortable with this view. It does not require erasure for novelty to appear. New configurations do not overwrite old ones by force. They follow from them, constrained and enabled by what already exists. The universe accumulates structure not because time moves on, but because relations compound. In this ledger, the past is not gone, it is encoded. Traces remain in particles, in radiation, in the arrangement of matter, in the correlations that shape what can happen next. The future is not waiting ahead. It is a space of possibilities defined by the present configuration, and the present itself is not a blade slicing through reality. It is simply the configuration currently being referenced by interacting systems. This removes a quiet anxiety that often hides inside the idea of time flowing, the sense that moments are being lost as they pass. In the physical description, nothing is swept away. What changes is not existence, but relevance. Some configurations no longer influence what happens locally, others do. That shift in influence is what gives the impression of passage. From within the universe, this distinction is almost impossible to feel. Experience is built from limited access. A system can only interact with what is nearby in spacetime, and recent in correlation. Memory fades, signals disperse, and so attention narrows to a thin slice of the vast relational structure. That slice is what feels like now. Quantum field theory does not elevate that slice into a moving entity. It treats it as a local condition, dependent on interaction, information, and scale. What feels immediate to one system may be inaccessible to another. There is no contradiction, because there is no global flow demanding agreement. This perspective also explains why physics remains predictive without invoking a moving time. The universe does not need to head anywhere. It only needs to be consistent. Given a configuration, the laws determine how likely various successor configurations are. That is enough. Direction emerges from constraint, continuity emerges from stability, experience emerges from persistence. Seen this way, spacetime's stillness becomes a source of trust. It is because spacetime does not flow that distances remain meaningful, that durations can be compared, that cause and effect remain ordered. A flowing framework would undermine its own role. By remaining fixed, spacetime allows change to be legible. And so, the final image is not one of motion beneath reality, but of patience. The universe does not hurry. It does not advance. It does not leave itself behind. It simply relates to itself, moment by moment, according to laws that are unwavering and calm. From inside those relations, we feel time pass. We grow, remember, anticipate. But beneath that intimate experience is a deeper stillness, one that does not oppose becoming, but makes it possible. Spacetime does not flow because it does not need to. It holds the universe steady enough for change to mean something at all. As this understanding deepens, something gentle happens to the question itself. Asking how spacetime flows begins to feel like asking how silence moves through a room. The question points toward motion, but what matters is not motion at all. What matters is structure, consistency, and relation. Quantum field theory offers a universe that is complete without momentum beneath it. Fields evolve, patterns persist, interactions propagate, probability shapes outcomes. All of this unfolds within spacetime without requiring spacetime to do anything except remain what it is. A framework that does not rush. A geometry that does not advance. A set of relations that simply hold. There is a quiet relief in this picture. Nothing is being pushed along. Nothing is being lost behind us. Each configuration exists because it is allowed by the one before it, and it leaves traces that shape what can come next. The universe does not hurry because it has nowhere to go. It does not lag because nothing is pulling it forward. From within this stillness, change feels vivid. From within persistence, continuity feels real. From within ordered succession, direction feels unavoidable. But these feelings belong to systems that track change, not to spacetime itself. Quantum field theory is careful never to anthropomorphize the universe. It does not grant it intentions or motion where none are required. It describes what exists, how it relates, and how it evolves. And in doing so, it quietly removes the need for time to flow at all. Spacetime becomes something like a deep calm beneath activity. Not empty, not passive, simply stable enough to let everything else happen. It defines what can touch what, how fast influence can travel, and how change can be ordered. Beyond that, it remains silent. This silence is not absence, it is support. Without it, there would be no locality, no causality, no persistence, no memory. Change would lose its meaning if the structure that relates moments were itself unstable or in motion. So the universe rests on something remarkably simple, a fixed framework. Fields everywhere, laws that connect one configuration to the next. And from that simplicity, everything unfolds. Time as lived continues to feel rich and textured. Moments matter. Sequences carry meaning. Growth and decay feel real. Quantum field theory does not deny any of this. It explains why it can happen without invoking a moving present or a flowing backdrop. Nothing needs to arrive. Nothing needs to depart. The universe is already sufficient to itself. Space-time does not flow because flow would add nothing. Stillness is enough. And within that stillness, fields continue to change, patterns continue to persist, and the universe continues, not traveling forward, but coherently, lawfully, quietly becoming. Staying with this picture a little longer, it becomes clear that nothing more needs to be added for the universe to make sense of itself. There is no missing motion, no hidden stream beneath events. What exists is enough. Fields change because the laws permit change. Order persists because structure is stable. Experience arises because some patterns are able to register difference across succession. Quantum field theory does not ask space-time to explain time. It asks it only to define relationships, how far apart events are, which interactions are possible, how influence spreads. Within those constraints, everything else unfolds naturally. The feeling of passage is not a flaw in the description. It is a feature of being embedded within it. This embedding matters. A system that can remember even a fraction of a second ago will experience sequence. A system that can compare states will experience before and after. A system that can anticipate will experience direction. None of these require space-time to move. They require only that the universe be consistent enough for comparison to work. When that consistency is present, even briefly, experience blooms. Not because time flows, but because patterns endure, long enough to notice their own change. The sense of continuity is not imposed from outside. It is generated internally, wherever structure persists. Quantum field theory quietly supports this everywhere, from the stability of atoms to the coherence of light to the reliability of clocks. The theory explains why patterns do not dissolve instantly. It explains why something can remain long enough to become something else, and that is all becoming requires. At no point does the theory gesture toward a global now sweeping across space-time. At no point does it require a universal tempo. The universe does not keep time. Systems do, and they do so by tracking change against their own internal regularities. This reframes even the language we use. Past and future are not places. They are relationships between configurations. The past is what has left records. The future is what has not yet been constrained by them. The present is where interaction is occurring. None of these need motion to exist. As this settles, the question of flow becomes softer, less urgent, almost unnecessary. It was never wrong to ask it. The intuition behind it is real. Change does feel like movement, but the answer reveals something gentler than expected. The universe does not move in order to change. It changes because its structure allows it to. Space-time in this light becomes something like a deep, still surface that never ripples, even as patterns appear upon it. Not because it resists change, but because it does not need to participate in it. Its role is quieter than that. It allows change to be ordered, comparable, and meaningful. Nothing here asks for belief. These are not interpretations layered on top of physics. They are what remain when the mathematics is taken seriously and the metaphors are carefully released. When we stop asking space-time to behave like a substance, what remains is clarity. And within that clarity, the universe feels calmer rather than emptier. Less hurried, less fragile. Change continues, endlessly without being pushed. Moments succeed one another without being carried. Space-time does not flow, it stays. And because it stays, everything else is free to change. If we remain here, inside this still framework a little longer, another quiet realization begins to surface. The universe does not appear to be aiming at an end. There is no final moment that space-time is moving toward, no destination pulling events forward. Quantum field theory describes evolution without a goal, succession without arrival. Each configuration exists because it follows lawfully from others, not because it is closer to something ahead. Change is not progress in a cosmic sense. It is simply consequence. Fields interact, energy redistributes, correlations spread, structures form and dissolve. None of this requires direction beyond what probability and constraint already supply. This absence of destination is important. If space-time were flowing, it would be natural to imagine it carrying the universe somewhere, even if we did not know where. But in the quantum field picture, there is no such trajectory. The universe is not on its way. It is not late. It is not early. It is simply arranged, moment by moment, according to rules that do not look ahead. From inside this arrangement, anticipation still exists. Systems predict, organisms plan, minds imagine futures. But these are local constructions built from memory and inference. They do not reflect a motion of time itself. They reflect how systems embedded in ordered change learn to navigate uncertainty. Quantum field theory allows this because it treats the future as open, not because time is approaching it, but because present configurations do not fully determine what comes next. Probabilities branch, outcomes diverge, and yet all of this branching occurs within a space-time that remains unchanged as a framework. This can feel counterintuitive at first, because human experience is saturated with narrative. We feel as though we are moving through a story. But physics does not require a storyteller. It only requires consistency. And consistency is exactly what space-time provides, by remaining still. There is something quietly generous about this. By not flowing, space-time allows every configuration to stand fully in relation to others. Nothing is rushed away. Nothing is prematurely erased. The universe does not have to forget in order to continue. It carries its own structure forward through lawful connection, not through motion. This also means that the calm we associate with stillness is not in opposition to change. It underlies it. Space-time stillness is what allows change to be intelligible rather than chaotic. Without a stable framework, there would be no reliable notion of before and after, no way to compare configurations, no way for cause and effect to remain coherent. Quantum field theory leans heavily on this stability. Its predictions work because space-time does not drift, warp unpredictably, or evolve on its own. The laws depend on a fixed structure so that relationships remain meaningful across moments. And so, beneath all the activity, there is something profoundly steady. Not frozen, not inert, simply reliable. A geometry that does not need to announce itself. A framework that does not need to participate in the drama unfolding within it. From inside that framework, life feels urgent, decisions matter, moments feel fleeting. But the deeper description remains calm. The universe is not slipping away beneath us. It is not being carried along. It is holding together. Space-time does not flow because flow would introduce urgency where none is needed. What exists is succession without haste, change without pressure, becoming without motion, and within that quiet order, everything that can happen does. If we remain with this understanding, the universe begins to feel less like something unfolding in time, and more like something sustained by consistency. There is activity everywhere, yet no urgency behind it. Fields change because they must obey their equations. Interactions occur because they are allowed. Nothing accelerates the universe toward a next moment. Nothing delays it either. Quantum field theory does not contain a notion of waiting. A configuration does not linger until time arrives to move it along. It exists as it is defined, connected to others by lawful relationships. When change occurs, it does so because the conditions for change are met, not because a clock has advanced. This is a subtle but profound distinction. In daily life, we often feel as though time passes independently of what happens within it. Minutes slip by even if nothing changes. But in the physical description, time does not accumulate on its own. What accumulates are events, records, correlations. If nothing changes, there is nothing to count. This does not mean that stillness halts the universe. Even in the quietest regions of space, fields fluctuate. Even in apparent equilibrium, microscopic change continues. The universe is never frozen, but neither is it pushed forward. Change occurs because it is permitted locally, not because it is demanded globally. This is why the deepest physical laws feel so patient. They do not hurry outcomes. They specify relationships and let consequences follow. The universe is not impatient for its own future. It is not trying to arrive anywhere. It simply unfolds according to what is already allowed. From within this unfolding, rest and motion take on new meanings. Rest is not the absence of time. It is the persistence of configuration. Motion is not the passage through time. It is the spread of change across space. Both are descriptions of field behavior, not of space-time itself. Quantum field theory treats these distinctions with care. It never conflates sequence with motion. It never treats ordering as transport. It never asks space-time to do the work that interactions already explain. And because of this restraint, the picture remains coherent even as it grows vast. There is a calm that emerges when motion is no longer required at the foundation. The universe does not need to be carried. It does not need momentum to exist. It does not need a present to chase the future. It only needs laws that relate what is to what can follow. And those laws are astonishingly stable. They do not age. They do not drift. They do not tire. The same principles that governed the earliest moments of the universe continue to govern now, not because time has flowed faithfully, but because the structure that defines change has remained intact. From inside this structure, living systems feel urgency because they are fragile. They feel time passing because they change irreversibly. They feel pressure because they exist far from equilibrium. But these feelings belong to systems, not to space-time. Space-time itself remains neutral. It does not hurry decay, it does not rush growth, it does not sweep moments away. It simply allows differences to be ordered and compared. That allowance is enough for everything else to happen. If there is rest at the foundation of reality, it is not the rest of nothing happening. It is the rest of nothing being forced. The universe proceeds without compulsion. Change arises without pressure. Succession unfolds without movement. Space-time does not flow, it remains. And within that remaining, the universe continues to change, not because it must go somewhere next, but because, moment by moment, the conditions for change quietly persist. As we continue to remain inside this understanding, the universe begins to feel less fragile than intuition often suggests. If space-time were flowing, moments would be constantly slipping past, carried away by something unstoppable. But in the picture offered by quantum field theory, nothing slips, nothing is swept downstream. Configurations change, but they do not vanish by being pushed aside. What changes is relevance. Certain correlations stop influencing what happens next. Certain records become inaccessible, certain structures dissolve. But this is not because time has moved on. It is because interactions have redistributed information. The universe does not lose its past. It simply stops consulting parts of it. This distinction is subtle, but it changes how continuity feels. The present is not a thin edge slicing away what came before. It is a region of active interaction, embedded within a much larger structure of relations. The past is still there in principle, encoded in radiation, in particles, in long-range correlations. It is not erased by motion, it is outpaced by complexity. Quantum field theory allows this because it treats evolution as lawful replacement, not consumption. One configuration follows another without destroying it in any absolute sense. The laws never say that the earlier state must disappear, they only say how the next one depends on it. This helps explain why the universe feels stable across immense spans of time. Ancient light still reaches us. Early conditions still influence large-scale structure. The cosmos remembers, not because time preserves it, but because the laws allow information to propagate and persist. From within this remembered universe, time feels precious, moments feel fleeting, but the physical description reveals a deeper patience. The universe is not rushing away from its origins. It still carries them quietly in the structure of fields that fill space-time. This patience also explains why prediction is possible at all. If space-time flowed unpredictably, if the framework itself shifted, the relationships between events would dissolve. But because space-time remains fixed as a structure, patterns remain legible, laws remain applicable, understanding remains possible. Quantum field theory depends on this endurance. Its equations assume that space-time today behaves like space-time yesterday, not because time flowed faithfully, but because the structure that defines distance and duration remains unchanged. Without that assumption, the theory would collapse. And yet, within that unchanging framework, novelty still arises. New configurations appear, new structures form, new patterns persist. Change does not require the framework to evolve. It only requires interactions to occur within it. This is where the calm becomes almost tangible. Nothing is chasing the universe forward. Nothing is eroding the present from beneath. There is no hidden urgency at the foundation. There is only lawful succession, occurring because the conditions for it continue to be met. From inside this succession, life feels temporary because it is delicate. Moments feel brief because attention is limited. But these feelings do not reflect a universe that is losing itself to time. They reflect systems that exist far from equilibrium, navigating change with finite resources. Space-time itself does not share that fragility. It does not age, it does not tire, it does not thin out as moments pass. It remains what it is, allowing the universe to explore its own possibilities without being pushed along. And so, the idea of flow dissolves completely here, not because it was foolish, but because it was unnecessary. The universe does not need to be carried in order to continue. It does not need a current beneath it. It does not need a moving present to feel alive. It needs only consistency. And that consistency is what space-time provides by remaining still while everything within it changes. At this point, change itself begins to look different. Not as something that carries moments away, but as something that rearranges relationships while leaving the underlying structure intact. Quantum field theory describes evolution as substitution, not erosion. One configuration replaces another, but nothing is swept aside by motion. The universe does not slide forward. It reconfigures. This matters because it reveals why continuity never truly breaks. Even dramatic change does not sever the thread of relation. When a star explodes, when matter disperses, when structure collapses, the fields involved do not leave space-time. They reorganize. Energy redistributes. Correlations spread outward. What was concentrated becomes diffuse, but it remains part of the same ordered whole. There is no moment when space-time must advance to allow this to happen. The conditions for change already exist. The laws already connect one arrangement to the next. Space-time simply provides the stable geometry that allows these transitions to be described at all. In this sense, the universe always keeps its footing. No matter how complex the change, no matter how violent the interaction, there is never a need for a deeper motion to carry events along. Everything that happens does so in place, within the same relational framework. This is why even the most extreme physics remains calm at its foundation. Particle collisions at enormous energies, the birth of black holes, the early moments of the universe itself, all unfold without space-time needing to move. The drama belongs to the fields. The framework remains steady. From within experience, this steadiness is easy to overlook. Attention narrows. Change feels urgent. Moments feel scarce. But these sensations arise because systems like minds operate within tight windows of correlation. They can only track a small portion of the universe's ongoing reconfiguration. What falls outside that window feels lost, even when it is not. Quantum field theory does not share this limitation. It keeps track of relationships across all of space-time, allowing information to persist, propagate, and influence what comes next. Nothing is discarded by default. Relevance shifts, but existence remains relationally complete. This offers a gentler picture of impermanence. Things change because interactions alter their structure, not because time removes them. What dissolves does so into the broader field, becoming part of other processes. Change is not disappearance. It is redistribution. And because space-time remains still, This redistribution never loses its reference frame. Distances remain meaningful, durations remain comparable, causes remain linked to effects. The universe does not wobble beneath its own evolution. In this light, spacetime's stillness is not a backdrop to be ignored. It is an active kind of patience, a refusal to interfere. By not flowing, it allows everything else to change without confusion. The universe does not rush through time. It rearranges itself calmly, lawfully within a structure that never needs to move in order to hold it all together. As we let this come to a close, the question that began, it has quietly changed shape. How spacetime flows is no longer something to be solved, but something to be released. In quantum field theory, spacetime does not need to move in order for the universe to live, change, or feel alive from within. What remains is a picture of deep steadiness, a framework that does not hurry, a geometry that does not advance. Within it, fields evolve, interact and rearrange themselves endlessly. Stars form and fade, particles appear and dissolve, patterns persist long enough to notice themselves changing. None of this requires a current beneath reality. Time, in this view, is not a river carrying moments away. It is an ordering of change, a way to say that one configuration follows from another. The sense of passage arises because systems like minds and clocks are built to compare, to remember, to anticipate. They track succession, and succession feels like motion when you live inside it. Space-time itself remains calm throughout. It does not push the universe forward. It does not erase what has been. It simply holds the relationships that make change meaningful. By staying still, it allows distance to remain distance, duration to remain duration, and cause to remain connected to effect. There is something quietly reassuring in this. Nothing is being rushed away beneath you. Nothing essential is slipping through an unseen current. The universe is not in a hurry to leave itself behind. It is not being carried anywhere. It is continually reconfiguring, lawfully and patiently, within a structure that does not need to change in order to support change. From within this structure, life still feels vivid, moments still matter, experience still unfolds with texture and direction. Quantum field theory does not flatten that richness. It explains how it can arise without requiring a moving present or a flowing backdrop. So the answer settles gently. Space-time does not flow. It does something quieter and more fundamental. It stays consistent enough for everything else to change, and within that consistency the universe continues, not pushed, not pulled, simply connected, moment by moment, by laws that do not rush and do not pause. Change goes on, space-time holds, and nothing more is needed.